Conceptual geometry, Unit 9, Day 4, angles with tangents, secants, and chords. The first theorem we are going to talk about is a tangent to a circle. A tangent, remember, is a segment that touches the circle in exactly one point. So there's a picture of a tangent right there. And the theorem is that it's perpendicular to the radius or diameter. So if you draw a radius from the center to that point, that's a right angle. Now it could also be a diameter. The diameter would just go all the way across the circle to the other side. So either one of those will be perpendicular to that tangent. And that's it. It's pretty easy. We're going to base the rest of our examples off that one theorem and then things that we've learned already. So in our first example, there's no work to show, there's no numbers, but what you should notice here is that you're given a tangent and a diameter, so you know they are perpendicular. X equals 90 degrees, piece of cake. That angle right there is a right angle. So now we're going to apply that to other problems that we've talked about throughout the year. This is the first time we're seeing a right triangle that's like inside and outside the circle. So it doesn't really make a lot of sense to me, except the fact that the radius and the tangent form a right angle. X represents the hypotenuse of this triangle. So from last unit and then back in unit 3, we've got the Pythagorean theorem. 5 squared plus 12 squared equals x squared. So it's really just a right triangle problem that they try to incorporate into a circle. I'll do this kind of quickly, but I expect you to put that into a calculator. That gives you 169 equals x squared. And then you just square root both sides. X is 13. The next example is one of the trickiest ones in the unit, and here's why. The angle we're looking for is this one. And the reason it's tricky is because it's not in the formula sheet. It's not an angle that we find directly. We find it indirectly. Here's how you find it indirectly. You notice that this angle I'm highlighting in red is an inscribed angle. And an inscribed angle is equal to half the arc. So the angle I highlighted in red is 50 degrees. Now we use something back from Unit 1, the fact that if two angles form a straight line, they must add up to 180. So x is going to be 180 minus 50. And the reason that that's so challenging is, like I said, you cannot find it directly. You have to find the angle on the other side of it first, because it's inscribed, take half the arc, and then subtract it from 180. So we'll see this from time to time. Just remember, don't worry about trying to find a formula for it. Use other methods to get it. And notice we're going to practice that 3 more times right here. And the next example, the angle I need to find is this one. And they're trying to trap you here. They're trying to make you take half of 130, but that's not the correct answer. The way to get this angle is first to find the inscribed angle. Well, if you notice, the arc of the inscribed angle is not given to us, so it's going to be harder than the one we just did. But what I do know is that this arc here is 150, and that arc there is 130. So if I want to find the red arc, I need to take those 2 green arcs and subtract from 360. So let's do that first. 360 minus 150 minus 130. All right, and that's going to be 80. So my red arc is 80. If the arc is 80, the inscribed angle is going to be half of that, or 40. So now to find my angle x, I'm using the fact that those 2 angles add up to 180, and x equals 180 minus 40, or 140. And that is one of the most challenging types of problems we are going to have this unit. In the next example, it should be a little bit more straightforward than the one we just did. So again, we're trying to find this angle. And because this is a secant, you can't find that directly. So we're going to, once again, find this inscribed angle, which is pretty easy. It'll be a decimal because we're going to take half of 75. Half of 75, I believe, is 37.5. Now to get x, we just have to take 37.5 and subtract it from 180. So 180 minus 37.5, I believe, is 140, that should be a 5, 142.5. And the last one. And by this point, I'm hoping you guys kind of get it. We can't find that angle highlighted in yellow. So we have to take this angle on the other side of it, which is always inscribed, and find that one. So the arc it intercepts is 70. Half of 70 is 35. So the angle on the other side of it is 35. To get x, take 180 minus 35. And that gives you 145. So those are the trickiest ones. Notice we spent most of the time finding that angle. A diameter and a tangent are 90. That's pretty easy. We don't need to practice that a whole lot. But this one right here we do need to practice. In our first official example here, we are going to tackle an algebraic concept that we introduced back in Unit 3. If you notice, we've got this giant circle problem. One thing I do notice is that it has a diameter, which always divides a circle into two equal parts. So that's 180 and 180. Now, I don't know any of the individual pieces yet, so I can't label anything. But over here, they're telling us that arc AD to DF to FC is in the ratio of 2 to 3 to 4. So I want you guys to think back what we did earlier in the year. We said, oh, whenever I give you a ratio, you make them x's, 2x, 3x, and 4x. So take a look. Arc AD, I'm going to write it just on the inside. Arc AD is 2x. Arc DF would be 3x. And arc FC would be 4x. Now, since I told you guys we had a diameter creates a semicircle, and in a semicircle, we have 180 degrees. So I can create a pretty simple equation understanding that concept that looks like this. 2x plus 3x plus 4x equals 180. Now we have to use that up all our x's. Well, that's simple. 2x and 3x is 5x plus 4x. That's 9x equals 180. Divide by 9. So x equals 20. Now, once you know what x is, you can go back and you can find the length of each individual arc by how many x's it is. So arc AD, right here, I'll highlight in red, is 2 times 20. So that arc is 40. Arc DF, which is 3 times x, 3 times 20 is 60. So obviously this is not drawn to scale. They don't want you trying to guess, so they don't usually draw it to scale. And then arc FC is 4x. 4 times 20 is 80. So now I know those three arcs. So up above, I can answer that question. Find arc AD, that's 40 degrees. And then in the next piece of information, it says if arc AB, so let's find it. Arc AB is 70. Arc AB, so this arc right here is 70. Now I don't care what else it tells me to find. Remember, don't necessarily do these in the order that you see them. I want to find all of my arcs first. And since I have a diameter, I know that arc BC, the only arc that's missing, can be easily calculated by taking 180 minus 70. So that arc's 110. Maybe I need that information later on. Maybe I don't. But I need to find that arc before I can get other angles. So now we'll use all the arcs to get the angles pretty easily. First one here, it says find the measure of angle ADB. Here's angle ADB. It is inscribed. It's the second angle on your formula sheet. Half the arc. 70 divided by 2, 35 degrees. Put it in the diagram. Sometimes we have to use the circle. Other times we can use things like supplementary angles form a straight line, or the three angles of a triangle add up to 180. Next, I want to find the measure of angle DAC. So I'll use a bunch of different colors here just to try and highlight the angle. I know it gets a little bit cluttered, but hopefully it helps you to visualize. DAC is another inscribed angle. But be careful. Its arc is made up of two arcs. So to find this, I would probably take 60 plus 80, so that's 140. Then you've got to take 140 divided by 2, so that would be 70. So this angle is going to be 70 degrees right here. Next, I want to find the measure of angle FOC. FOC, all right, so let me use this. I use red, FOC. Now, for the first time in this example, we're dealing with a central angle. This is the first angle on your summary sheet. Central angle is equal to the arc. No work to do there, really. Just know it's the same as the arc, so that's 80 degrees. And then the last one, FCG. FCG, all right, so this one's going to be a little bit tricky. FCG, this is kind of what we did on the other page. I can't get this one directly because it involves this secant here. This part here is sticking out of the circle. Could be at any random angle. I don't know. So what we are going to do is find the one on the other side of it. That angle right there is inscribed. So it's going to equal half of the arc. And notice again, I'll highlight that arc. 60 and 40, that's 100. 100 divided by 2 is 50. So the angle on that side is 50. And after all that work, now I can get this one by taking 180 minus 50. So you can see why these circle problems can get very tricky. It's got multiple parts, a lot of parts to these, but they're just like giant puzzles. That's all they are, giant puzzles, and you got to try and figure it out one piece at a time. All right, our last example will be a little bit more straightforward. We don't have to worry about the ratio. It's going to give us two pieces of information, and we can use that to get everything else. Now, once again, I recognize that I'm given a diameter. Diameters are very nice to have because it creates two semicircles, each one containing 180 degrees. All right, so measure of angle BOA. BOA is 140 degrees. Now that's a great angle to be given because that's called a central angle. A central angle is equal to the arc. So I know this arc right here is 140. I'm not going to determine, find what is listed first in the list. I'm just going to get what's easiest. Next, I know the measure of angle CAD. CAD is 30 degrees. So that's this angle right here. CAD. That is an inscribed angle. I know an inscribed angle is equal to half the arc. So its arc over here must be 60. Easy calculation. Just multiply by 2. Now I can go quickly for all the rest. All right. On the bottom here, arc AD is 180 minus 60. So that's 120. Up top, arc BC is 180 minus 140, so that's 40. All right, so now maybe I found some stuff in this problem. Arc BC, I just calculated, that's 40 degrees. I can put that in here. Arc AB, that's 140. Let's find all my arcs. Part D. Arc CD is 60 degrees. And F arc AD is 120. Now angles. Angle ADB. Let me use a different color here. ADB, that's inscribed. but I've got to take half of 140 to get that. That's